Hello dear students, welcome back to our YouTube channel. Uh, as you know that we are studying about integral transform, in which we have completed our first chapter, that is beta and gamma function, in which we have seen definitions, properties and many transformations of beta and gamma function, their relation and their applications in real life. Now we have started our new chapter, that is Laplace transform, integral transform. In which we have started our first chapter, Laplace, second chapter, Laplace transform. Now we have just started this chapter, Laplace transform, and we have just taken one or two lectures based on these. And we have studied about the first definition, that is piecewise continuity. After that, we have studied about the function of exponential form. In first definition, we have studied about if we have a interval, say AB, and if we have finitely many subintervals of that interval AB, and a function is continuous in each subinterval, but it is discontinuous at the end point of the integral, then it is called the function. The function is called piecewise continuity. And in function of exponential form, we have studied about the formula or the order, exponential order, that limit x tends to infinity e raised to ax f of t or f of x is finite number. F of x be any real function, real valued function, and if we take limit x tends to infinity e raised to ax into f of x, e is equals to finite number, then we can say that the function of exponential order. And if it is infinity, then it is not function of exponential order. We have learned these two definitions, important definitions, in previous lecture. Now we have seen some examples which is based on exponential order, function of exponential order. Now we will go to see one more definition which is quite important to understand, and that definition is called as function of class A. Function of class A. Function of class A. And the definition, the collection of both two definitions. In this definition, if we do collection of these two definitions in this function, then it is called function of class A. A function f of x is said to be class A if a function f of x is said to be class A function the first one, if f of x is piecewise continuous for all x greater than or equal to 0, and the second part is f is of exponential order. F of x is of exponential order. if a function satisfies both of these two definitions, then that function is called function of class A. Now we will see important definition, that is integral transform. Integral transform, an improper integral of the form. The fourth one, integral transform. An improper integral of the form, an integral transform, an improper integral of the form minus infinity to infinity k s p f of t. If such type of function is happened, then it is called integral transform of f of t. Then it is called integral transform. Form of f of t. Correct? It is the integral transform of f of t. Here we have or integral transform of f of t. Here KST is kernel function. Kernel function. We have two definitions. In previous lecture we have studied about piecewise continuity. Then we have studied about functions of exponential order. Today we have seen about function of class A, in which a function f of x is said to be class A function if f of x is piecewise continuous for x greater than or equals to 0 and f of x is of exponential order. And after that we have seen integral transform, and it is defined as an improper integral of the form integration from minus infinity to infinity k x t f of t dt. Then it is called integral transform of f of t, small f of t. And here also a small f of t, where kst is a kernel function. Now we will see the important definition, Laplace transform. The most important definition, Laplace transform. Laplace transform. And it is defined as f of t be a real valued function defined on interval minus infinity to infinity if f of t be a real valued function defined in interval minus infinity to infinity such that f of t is equals to 0 whenever t less than 0. Correct? F of t is equals to 0 for all t less than 0, for all t less than 0, and for t greater than or equal to 0, integration from 0 to infinity e raised to minus st f of t dt. This is called Laplace transform. is called Laplace transform. Is called Laplace transform, and it is denoted by Laplace transform of f of t. That is Laplace denoted by Laplace transform of f of t, integration from 0 to infinity e raised to minus st f of t. So today we have one more definition, that is Laplace transform, in which we have seen that if f of t be a real valued function defining the interval minus infinity to infinity such that f of t is 0 whenever t is less than 0 and whenever t is greater than or equals to 0, the Laplace transform of f of t is integration from 0 to infinity e raised to minus st f of t dt is called Laplace transform, and it is symbolically denoted as Laplace transform of f of t, and Laplace transform of f of t also denoted as capital F of s or f of t. To be sufficient or easy to understand, or we can write variable as f of s. Whatever we want to write, we can write f of t or f of s. So I have completed all the definitions which are very useful for the Laplace transform. In next lecture we will try to solve, try to go with some basic properties of Laplace transform, and after that we will try to solve or go with application of Laplace transform. Till then, stay watching our videos and keep tuned with us. Thank you.